So let's talk about Bayes' theorem. Bayes' theorem essentially covers the probability of an event A being true given another probability B is true. So the probability of A being true given B is true is equal to P A and B over P B. And this is the very general formula that you can use to cover what P A given B is equal to. Now, the opposite is true, where A and B is swapped, and then if you were to isolate P, B, and A from this, you would get P, B, and A equals to PA times P of B given A. And the beauty here is that we can actually replace this into here because PA and B is the same thing as PB and A. And now, if you were to plug in this into the numerator, you would get this new third equation. So the choice of using either of these equations is just going to come down to what information you have. If they give you PA and B and PB, you use this equation, and if they give you PB given A, PA, and PB, you go ahead and use this equation. So let's take a look at an example here. What is the probability of having two girls given at least one girl? Now, we're talking about a situation where if you are a parent and you're going to have two babies, you're going to have either a boy or a girl as the first, and a boy or a girl as the second. So we're talking about, given you have at least one girl, what is the probability that you have two girls? And we're going to be investigating this. So the first thing I want to do is identify the events. So event A means that you're having two girls, and event B says that you have at least one girl. And now, using Bayes' theorem, we are able to rearrange this equation into this, and then let's go ahead and evaluate each of the probabilities inside of this equation. So, the first one we're going to take a look at is this probability of having one girl given you have two girls. Well, this would be pretty self-explanatory because if you are given that you have two girls, the probability of you having at least one girl is 100%. There's never a case where if you have two girls, you don't have at least one girl. So this is straight up just 100% or just one. And now let's take a look at the probability of having two girls. So if we go back to the fundamental counting principle, I could really just say that the first child, being a girl, is a chance of 1/2, and the second chance is also 1/2. So this is going to be 1/4. And now, if we're talking about the probability of having at least one girl, that means we are having essentially a combination that has at least one girl. So what I'm going to do here is draw out all of the combinations that are possible. So you can either get a boy-boy or a boy-girl. You can also get a girl-boy, and then you can get a girl-girl. And now, as you can see, the events for which there is at least one girl is going to be boy-girl, girl-girl, and girl-boy. And that is 3/4. So that is what we put into here. And now, once we compute this, we would realize that the probability of this is going to be 1/3. So that is the answer. And that is how you deal with Bayes' theorem.